Okay, here we go. I know that you want to get out and get some dinner, so let's get the show starting. Welcome everyone to our 7 Habits session. My name is Lila Rousseau. I'm co-presenting with Adam Radford. We both joined Cisco in 1999. He's from Australia. I'm from Toronto, Canada, so that's different. And fun enough, we have a lot of similarities. So actually, we kind of realized when building this slide, we are both avid exercisers, world travelers, bloggers. We've been Cisco Live speakers for many years. And we've both been working together in the journey towards automation in the enterprise with different controllers, starting with DNC, APKM, and now DNA Center. And today and together, we have 20 years of experience working in this space. So, questions, there's a WebEx space. Hopefully you're already subscribed or added to that space. It's the name of our session. Adam will be answering questions while I'm presenting and vice versa. So why did we call this session 7 Habits? So what is a habit? A habit is something that we do without thinking, and hopefully a good habit is something that by doing it, we get benefits in the long term. So why did we call it habits? Because that's what we want to share today with DNA Center. We want to share things that if we do them long enough, you get used to doing them with frequency and then get the most benefit from DNA Center. Maybe a habit like brushing the teeth is a good thing. Some other habits like eating healthy might require a little bit more work. And the same thing with DNA Center. A lot of the things are going to be very straightforward. Some things that we talk about might require a little bit of change in our operational model. But in the long term, we hope that this is going to be very beneficial for your environment and your operational costs. So tons of topics that we are going to cover today. And the first one is what we call understanding and embracing device controllability. How many of you are familiar with device controllability in DNA Center? Sorry, I should ask, how many of you have DNA Center today? How many of you are using DNA Center in production? There you go. And now the other question, how many of you know and understand device controllability? Okay, a few, not bad, not bad. So what is device controllability? DNA Center does a ton of things. So we are leveraging information that it comes from the network so that we can provide compliance, we can provide network health, we can provide client health. All those things come from the network devices. So network devices have to be configured to send all this information to DNA Center. Obviously, since we are talking about automation, all these configurations need to be automated by DNA Center. And we call all these features that we push into the network devices so that DNA Center can do its job, we call all that device controllability. So what happens when a device is added to DNA Center? We are going to get information from the device, and that we call inventory collection. So we understand the configuration, the ports, what VLANs we have configured, and so on and so forth. And we are also going to push features like SNMP traps, syslog, NetFlow to collect data from the network devices. This shows a switch. In this case, we show a wireless LAN controller. So when we do add devices in the network, typically we start with discovery. You can do it in other ways. You can do zero-touch deployment, you can do prime migration, but in some way you're going to add the device into DNA Center. This is where we do inventory collection, and eventually you're going to assign a device to a site. A site is a very important component in DNA Center. When we assign the device to site, that is when the bulk of device controllability takes place. So this is where we are configuring and automating all these features into the network devices. Eventually, if you want, and this is optional, if you want to also get application health information, we can enable telemetry. And on top of that, if you want to automate the configuration of your network devices, and that could be SSIDs in your wireless LAN controllers, that could be templates, you can take things a step further and leverage the provisioning workflow. So what happens when we assign the device to site? Again, this is where the bulk of device controllability lives. When we assign the device to site, the first thing that we see is a banner that tells us, hey, device controllability is enabled. Hopefully you have it enabled. You can disable, but we will not be automating all these features. And then on the right-hand side, it gives you the list of features that we are pushing to the network devices as part of this umbrella. So what we need to also know, I forgot, and we can give you a config preview. So if you want to really understand what is being pushed to that network device, and that is dependent on the network device, what hardware, what version of code, and the version of DNA Center, so there's going to be some differences there, but you can use the config preview. Now, the capabilities or features that are going to be pushed in the umbrella of device controllability can also be customized. So in this case, we go to Design, Network Settings, Telemetry, and this is where we customize these capabilities. Having said that, in these 7 habits, our recommendation is that we keep DNA Center as being the receiver of all these features. Example, SNMP. So by default, we have that SNMP is going to be the destination for the traps. Ideally, you are going to leave that default. If you remove that default, we are not going to be receiving traps, and we will not be able to perform all the functions. Example, we have compliance, we have configuration information. What happens if someone goes into a device and makes a change in the configuration out of band? DNA Center, by using device controllability, configures SNMP traps so that the moment that happens, the device will send an SNMP trap to DNA Center. DNA Center can say, OK, there's a new config. I need to go and resync and get the information from the device. If we eliminate this option, we will not get the traps, and we will not have the latest config. What we could do, though, first, you could decide not to check this box, so that's an option. It's not recommended, but it's there. But for example, in this case, you can add a second SNMP server if you have another destination that you want the device to send traps to. And this type of customizations is available for all the capabilities that we push in the device controllability umbrella. So what do we want to know from a 7-habit perspective is that device controllability is key to the full performance of DNA Center. So we hope you embrace this capability, and that you know that there are options for customization that you can use for your network. We can look at what is being pushed to the network device, and also one thing that I didn't show in the slides, when you push device controllability, there's a lot of logs and information on everything that was pushed, and if there was any errors, you're going to see them there too. Now we're going to jump into habit number 2, and this is a big one, and this is the telemetry. So we, as part of device controllability, as part of enabling telemetry, we can collect a lot of telemetry from the network. So DNA Center can do a lot of things with this information that we receive, and we have examples here. And in my section, I collected a few areas that we think really resonate with my customers in Canada and Adam's in Australia. So the first one is the Wi-Fi 6 readiness dashboard. So in the end, because we have all this information on the network, and this is for clients and the network devices, we can give you analysis on how much of your network is ready for Wi-Fi 6 and Wi-Fi 6E. What percentage of clients, not customers, of clients are enabled for Wi-Fi 6 or Wi-Fi 6E and ready for the same protocols. If you have already Wi-Fi 6 or Wi-Fi 6E or both in the network, we can also give you metrics, and the metrics that we have today are around wireless latency and airtime efficiency, so that you can compare current or legacy protocols, depending on what you want to call them, with Wi-Fi 6 and Wi-Fi 6E, maybe allowing you to create a business case to move more clients or more access points to the newer technologies. we have a lot of reference slides. So we put a lot, so once you download the presentation, you can get all the slides. Next is PoE analytics. So PoE is key in this day and age. Obviously, we can power access points, we can power IP phones and video cameras, and any IoT type of technology. So having visibility on the power and power readiness in our network is very important, is key. So we have full visibility into the PoE infrastructure, and also we have special issues. Issues are the problems that DNA Center can detect that are related specifically to PoE. In terms of dashboard, we are going to choose a few things. First of all, I usually leave it for last, but I put it first. It shows you what percentage of devices have the advanced PoE features configured. Sometimes we forget that we have technologies like perpetual PoE and fast PoE, and if we do have IoT devices in our network that are taking advantage of PoE from our network, embracing these protocols is very advantageous. So here it gives you what devices, what percentage, and when you do click detail, what specific devices have those protocols and what devices don't have those protocols. Then we have the type of devices in terms of power consumption, so PoE, PoE+, UPoE, and every time you say view details, you get the information on the specific devices. Here we have the allocated and the remaining power. And this is for your whole site or the whole network infrastructure that you are choosing. Having said that, every time you do view details, and in this case, I chose the power distribution per PoE band. So in this case, I can say, well, I want to see all the devices that are consuming 90 watts per port, and you have a complete list of all the devices that are in this category. Same thing with the power analytics. In this case, I say, well, I have a whole bunch of remaining power in my infrastructure. Maybe I don't have to worry about it. But when I go into view detail, we can see what devices and the percentage of power allocated per device. So if there's a device that is already at the, 90% threshold, for example, that is something that you might need to reevaluate to see if that area requires more power. Then we have, again, I put it here. This is going to be a little bit of reference, but we have dashlets for different aspects of PoE consumption as well. Next is network services analytics, and this is a very important one because this is going to give us information on AAA and DHCP. And right now, this is specifically for wireless. Imagine if any of these is not working properly, then wireless clients will not be able to onboard in the network. So having the most visibility on AAA and DHCP can help us understand and try to find these problems before our actual users cannot onboard in the network. So what this is giving us are sites, so we can get visibility on the sites that have the highest latency or highest number of transaction failures. Either of these two can cause problems with AAA and DHCP, affecting the onboarding experience of wireless clients. And the other thing that is very useful is that we can see a mapping for both AAA and DHCP servers for every wireless LAN controller that we have in our environment. Now, what do we need to know about network services analytics? The first one I already mentioned. Right now, this is for wireless, and this is really specific to the 9800 wireless LAN controller, not the AirOS controllers. The other thing is that it's very important is that DNA Center does not talk to the AAA server or the DHCP server. This is being received directly from the wireless LAN controller. So we mentioned device controllability. One of the things that device controllability configures is streaming telemetry, both for wireless LAN controllers as well as switches. And the subscriptions, the streaming telemetry, TDL subscriptions that are providing the information for AAA and DHCP are here. You don't need to configure this manually. You don't need to know this. But if you're troubleshooting and not seeing either AAA or the HCP, take a look at your telemetry subscriptions, and those are the ones that are going to be providing this information. Now, most of the content that we are providing today is based on current version 2.3.3, but we will be soon releasing 2.3.5, and we are going to be sharing a few capabilities in 2.3.5. One of these is network services DNS. So we mentioned that we provide visibility on AAA and DHCP for wireless, but with 2.3.5, we are also providing visibility on DNS, and this is both for wired and wireless. In this case, we are using application telemetry. This is not telemetry subscriptions. And we get the server's average latency and also the successful and the failed transactions. Reference slide, all the areas that we can see in this network services DNS. I added a few snapshots on the dashboard so we can see, similar to the AAA and the DHCP, we can see the DNS server by location, and we get, as we mentioned before, failure and latency for the transactions. Next is application visibility. So application visibility allows us to get information of what applications are being used in the network. And for this, we had two ways of looking at the information based on what devices are providing the details. So on the one hand, we have what we call application visibility. And that is what applications are being used in the network and how much of those applications. So this is here. Certain devices have additional capabilities that can give us that information and a little bit of a step further. So we get what applications, how much, and also how good. That is jitter, latency, and packet loss. So what devices can give us all these metrics? Those are the Catalyst 9800 wireless LAN controllers when being deployed in local mode, as well as iOS XE routers. For switches and AirOS controllers, we are going to get what we call application visibility, and that is what applications and how much. Here we have a little bit of a telemetry cheat sheet in terms of versions that, again, you can get as a reference slide in the presentation. We also added what configuration is being pushed. This is not for you to go in and push that configuration manually. These configurations will depend on your version of DNA Center, on the hardware and the software of your device. This is just that you have some reference of one type of configuration, device configuration is being providing the application visibility information. Number 3, compliance and configuration management. How many of you are interested in compliance? I need hands. I asked this last session, and I was hoping everyone is looking for this. Okay, half is good. I can work with that. So in terms of compliance, we've been in a long journey to get where we are today. We've been adding, and we will be adding more and more capabilities. So from a compliance perspective, this is where we sit. We have compliance for software version. We are going to talk about upgrading switches in a minute. So if your device doesn't have the right image for the site, it's going to be tagged here. If we enable application telemetry and someone goes in and makes a change out of band, that is going to be flagged as a problem. End of sale, end of life dates are going to be flagged here. And then we also have what we call device configuration compliance violations, and we are going to talk a little bit more about that. But in the end, is if someone is changing any intent-based configuration pushed by DNA Center, all of these things are going to be flagged here. So let us go into a little bit more details on compliance. So from a software update, I mentioned that I will be giving you some glimpses into what's coming in 2.3.5. And this is the stack software version mismatch. So we all know that if we have a stack of 9300, 9200, the software versions of each member needs to match. But if there's an issue and it's not matching, now that is going to be flagged as a compliance violation. Next, it's the network profile compliance for switches. So network profile is a bucket for templates. In the switching world, it's a bucket for templates. So if you want to leverage templates to configure switches, you put them all in a network profile. So let's say that you go in and configure your switches with your templates. And now let's say that someone goes in and offline, they SSH into the device, and they remove some of the configurations. That is going to be flagged here as a network profile compliance violation. Let's see an example. So in this case, I have a template. I'm not the template master. Adam is the template master. My template is assigning a description to the interface. So yeah, but it will show the point. So here I'm assigning a description to the interface, and then I go out of band, I SSH, and I go in and remove that description. So what that is going to happen is that it's going to trigger that compliance violation, and it's going to tell me a few things. First, what template is the one that was removed from the configuration? In my case, it's called P description, and it's going to put in red the line that is missing from the current config that was originally being pushed by the template. So very clear indication on where the problem is. Compliance is very tied to another capability, which is called config drift. Config drift is going to take snapshots of different running configs. By default, we take 15, the latest 15 configurations, and we can compare them. So in this case, I'm comparing the current running configuration with a standard config. So any of these configs that we capture, you can put a name, and we can compare to that configuration instead of the last configuration. And at the top, it's going to give me more information. First, it's going to tell me that there are some changes. These changes are noted with a dot in purple, and purple means out-of-band config. So this is saying that someone that is called Lila SSH in from this IP address using this particular VTY, and there is an out-of-band config change, and this person added 322 lines. So very clearly indicated what the problem is from a configuration perspective. Now, we saw compliance violation of network profile with switches. Switches is simpler because the only things that we are configuring today, besides network settings that I'm going to talk about, are templates. For wireless, we can automate the configuration of the SSIDs. We can automate configurations of templates. But we can also automate configuration of SSIDs and any changes. Let's say that we configure an SSID from DNA Center, and someone goes in and makes a change. In this case, we are changing the FT adaptive attribute. Then it's going to be flagged here. We have another capability, which is model-based config. So this is a component that allows us to configure the wireless LAN controller with more advanced settings. And again, if you use model-based config for specific configurations and someone makes a change of one of those attributes, it's going to be flagged here. So this is the network profile compliance violation. We saw it for switches, which is mostly templates. For wireless, it's templates, model-based, and the SSIDs. Now, another thing that we added to 235 is the network settings compliance violation. One thing that we can configure in DNA Center is we go to a site, and we can configure all the network settings. And that is your NTP, your DNS, your DHCP, your AAA. And let's say that you automate the configuration of all this using DNA Center, and once again, someone goes in and makes a change. That, again, is going to be flagged in the network settings compliance violation. So in this case, that's my lab, and I went in and removed my name servers that I originally configured with DNA Center. The moment you do that, this is going to be flagged as a compliance violation for network settings. So now, we have all these problems. We have compliance violations of templates, your wireless SSIDs, your model base, your network settings. How are you going to fix all this? So there's an option, again, in 235 that is called Fix All Configuration Issues. So whatever all these issues are going to be flagged as config compliance violations. In this case, I have network profile, my templates, and network settings, my name servers, I can go in and fix. Not only that, you can have a preview. You can have DNA Center generating a preview if you want to see what is being pushed to the network device. What are the tips? If you're going to test this in the lab, the compliance, you need to wait 5 minutes. So let's say that you force a compliance violation, you remove a template or a name server, you need to wait 5 minutes for it to show up in compliance. And the other thing is that for these things to be triggered, the device has to be configured using DNA Center, so the network settings and the network profile. Next, go into device configuration management. How many of you, and I kind of said it before, but I will not take it if you don't remember, how many of you think that we do store the latest device configuration in DNA Center? Yes or no? And I get that question a lot. There's this idea that we discover the device, and that's the only time we store the configuration from the device. We always store the latest config. So anytime DNA Center makes a change, anytime there's an out-of-band change, I mentioned how we work with the trap, so we always store the latest config. Not only that, we saw the config drift. By default, we store overall 15 running configurations that we can actually compare. The problem is that for a while, we didn't do a great job in showing the config. So yes, for the switches, there's a tab that is called configuration that you can go in and look at the switch configuration. The thing is that for security reasons, some of the sensitive data, like passwords and certificates, we are going to mask them. So if you want to go in and look at the config, there's a button that says export. You export the config, all fine, but you cannot use that configuration to restore a new device because these fields are being masked. So what do we do if we want to actually use that configuration for other devices? Well, for that, we need to have the raw configuration. How do we get the raw configuration? One option is using APIs. So we have APIs that we can use to programmatically retrieve the configuration from the network devices. And with that, we are going to get a zip file. And this zip file per device is going to give us a running config, a startup config, and the VLAN database. Now, if you are not interested in leveraging APIs, that's not a problem. We can use the user interface to configure an external SFTP server to send the raw configurations to. Actually, this is also, if you want to have the mask configurations, you can do that too. But let's assume that you want the raw configurations. So you are going to configure the recurrence, so how often you want to do the backup. You can do the backup for all your sites, for a few sites, for some of the sites. But the most important thing is that you need to provide a username and password. Why? Because every time we do a backup, we are going to get a config file, not a config file. We're going to get a zip file. And in order to open that zip file, you need to enter the password that you added to create that backup. Again, we are going to give you a raw configuration, so we want to secure it in some way. So you are going to require to enter that password that you provided to perform the backup. Once you open that zip file, we're going to have a list of directories. Each directory or folder is going to be one device. And what's going to be inside the folder? Exactly what we got from the APIs. We are going to get the running config, the startup config, and the VLAN database. So in this case, we see that the config is raw. So this is actually one of the configurations that I got from my backup in the lab. It's a raw configuration, and you can use this to paste into another device. Habit number 4. Okay, we'll see what I get today. How many of you really like to update the software of your network infrastructure? Like doing it. Like, I want to do software upgrades. I want to have, you see, there's always someone. You like it, really? Good for you. How many of you like to upgrade phones? Your phone. I don't like even upgrading my phone. I envy you a little bit, I have to say. So, in order to make, not for you, no, for everyone, so to make our lives much easier, we are now automating the process of upgrading software in the infrastructure. So I'm going to do a quick demo, and then I'm going to pass it on to Adam to go a little bit deeper into this capability. Let me do one little thing. I prefer like this. OK. So the first thing that we need to do is assign a golden image to a site. So what is a golden image? Is the image version that you want to deploy in that particular site. And in order to do that, we need to download that image from Cisco.com, or you can upload from your computer. In my case, I'm going to go ahead and download the image. In my demo, I'm going to show a bulk update. Yes, I wish I could show 100 switches. I don't have 100, so I'm going to show you 4. But yeah, but a few 9200L, a few 9300. So what's happening right now is I'm just asking DNA Center to download the golden images. So when we are downloading the image, DNA Center is going to store that image in internal databases. But before it makes that image available to deploy in the devices, we are going to do internal checksums to make sure that the image has not been tampered with. And for that, DNA Center uses a file that it downloads automatically that is called known good values. So if you go into settings and you see something about known good values, that is the file that allows us to do the checksum for the files for the software upgrades. So that's why sometimes when you import the image, that is taking a while because it's importing, it's making all these checks for you. So when everything is available, everything has been imported, then we can now mark those images as golden image. I'm going to use 1792. When we mark image as golden, I'm going to mark image as golden for all the devices in that particular site, same image. However, we do have granularity, so you can mark different images using device role. So let's say that you have a 9300 in the access and a 9300 in the core for the same site. You can assign different images. We can also use tags. So let's say that you have some SD access switches in a site that are 9300, some non-SD access, and you want to have different images. You can use tags also to have that granularity. In this case, I'm using the same image for 9200 and for 9300 in the site. And my site is called the T branch site, so we see the T branch there. So once my images are marked as golden for both switch types, I'm going to go into update devices. This is going to be taking me to the inventory, and it's taking me directly to a view. We call it focus, but it's a view that is specifically related to software images. So the first thing that I see is that all the devices, so we have a filter, so it took me to a view that has a specific filter with all the devices that are outdated. So here I have all my devices outdated, and I have a hyperlink that says needs update. This is going to take me to a few pre-checks that has to be marked as green for us to proceed into the workflow. So now that we have all this in the inventory, I'm going to go ahead and upgrade my 4 switches. For this demo, I'm using switches, but I want to reemphasize that the same workflow is used for wireless, for routers. It's exactly the same workflow. So one of the other things that we are doing in software upgrades is separating the distribution of the image, which is copying the image in Flash. There are a few other things, but in essence, that's it, and the activation. In some cases, depending on your environment, you might or you might not need a maintenance window for the distribution. For sure, you will need a maintenance window for the activation because you are reloading the device during activation. So in this demo, I'm going to separate both tasks because I'm going to mimic what I see in general in my customers. So in this case, I'm going to do the distribution. And we have some predefined pre-checks and post-checks, but you can define your own. For that, we are going to leverage the command runner. So the command runner is a tool within DNA Center that allows us to automatically run commands in the switch. So this is the tool that I'm showing here. And any command that is valid in the command runner is also valid for the config check. So I always like to run my command in the command runner and then copy-paste it in the config check. So in this case, I'm doing a show IP interface brief. Next, the workflow is taking me to the activation. In this case, I'm going to skip activation because I'm going to do it at another time in a maintenance window. We'll do it in a minute, but let's pretend we are in a maintenance window. So now that we are in the last step, we are going to go ahead and request DNA Center to move on with the software upgrade. This task can be done now, so we are going to do it now, but it can also be scheduled at a later time. There's an image update status. This is a tab that gives us a lot of information of the process of upgrade. In my case, I'm also showing the CLI. Most likely, you will not have access to CLI, but I want to show you how we are installing the images in the devices. So once the distribution is done, we can go in and check the checks. In this case, we see that there are no differences, which makes sense, right? We just copied images in Flash, so nothing really happened, but it's good to check that everything is OK in all our switches. Now let's pretend we are in that maintenance window, so that's a few days later, the weekend, whatever, and now we are going to go into the activation. We are going to use exactly the same workflow, which is the image update. And in this case, I'm showing a different way of using the workflow. So in this case, I marked all the switches, but I'm going to say that I'm going to be excluding the last one. The last one is a Cat3K that I have there for a long time. So I'm going to upgrade my 4 Cat9K. And as you can see, DNA Center realized that distribution was done. So it completely skipped the distribution and is now taking me to the activation. Activation, we can keep the same pre-checks and post-checks. In this case, I'm going to remove some just to show that we can do it. So you can actually customize the pre-checks and post-checks as well. There's an option, and we get this question a lot, so I want to show it here. There's an option to do a Flash cleanup, and that is the remove install inactive command if you're familiar with it, and that's an optional check. I decided not to put it here to make it faster, but that's something that you can do and ask DNA Center to do at the end of the workflow. Now, again, this is going to go in and update the infrastructure, and we can always follow the process in the update status dashboard. So this advanced, so I'm using a video. This takes a little while to upgrade my devices, but we can see that all the devices now are up to date. All my Cat9K devices are now up to date. Everything is reachable. Everything is working just fine. We still have my Cat3K that needs to be updated. I didn't update it as I showed you before. So let's go in and look at the checks again. In this case, we see that there are some differences. So basically, we run the same command before and after, and we do a def. So in general, what happens is that some of the timers will look different. So this is exactly what happens here. So everything looks good, except that the hold time is a little bit different between both. But from an upgrade perspective, that's successful to me. And with that, that's our software upgrade process. And now Adam is going to cover a little bit more on software update, that it's not the demo.
Awesome. Thank you very much. Sorry, I was just answering a question in the team space. So for those of you who want to ask questions, encourage you to ask them in the team space, and we will do our best to answer them real time. So, okay, just thinking about Swim. How many people are using Swim at the moment? Yep. How many people would like to use Swim? Yep. So for me, it's one of the most popular features that we have. And one of the reasons that it is so popular is because of the speed with which you can upgrade devices. One of my customers is a bank. They have 1,000 branches. They have switches in each of those branches. And prior to this, it took them, it was a 6-month project to do a software upgrade across 1,000 branches. Now, the challenge that they had was that InfoSec said, if Cisco has a software vulnerability, you have 2 weeks to respond. 6 months, 2 weeks. So the software upgrade process was a way of automating that for them, and they can do that in 2 weeks. They could actually do it in a weekend if they wanted to, but because they separate out the distribution on one weekend and the activation on the second weekend, it's a 2-week process for them. There's a lot that we've done behind the scenes to try to make this simpler. So one of the things and the reasons that people use Swim is for software vulnerabilities. Inside the Swim process, inside the tool, you can get to see vulnerabilities that are open for the devices. And that gives you an understanding of the risk across the environment. We're also able to, when you download, when you download golden images, you're able to see in the golden image a list of advisories that are open for that device or that version of code. And also, if there are known vulnerabilities, you can ask for a recommendation. So it's going to go to CCO, look at the metadata, and see where those vulnerabilities are addressed, and automatically download that version of code, mark it as the golden image to make it easier for you. Golden image tagging, Leela mentioned tagging before. There's been some enhancements around tagging process. As Leela said, you've got the global golden image. You can override that locally. You can override that based on the role of the device, whether it's distribution or access. But we had customers who wanted more flexibility, which is why we introduced tagging as well. So I can define a tag on an image. I can define a tag on the devices. And then it will only be the tags that match that will determine whether that's the golden image for that particular device. And the reason that that's important is that I have customers who have test devices that are part of the network. They want to have a different version of code on the test device as opposed to the production devices, even though it's difficult to tell the difference between the two of them. So they just tag the test device as test, and then everything else gets taken care of for them. Now, the interesting thing about tagging, for those of you who've looked at the way tagging works in the inventory, you can define dynamic rules for tags. So for example, for this customer, the name of the device has test in it. So I can match on test in the name of the device and automatically assign the test tag to the device, so I don't need to keep manually tagging devices if I don't want to. Leela showed you this, an example of looking for outdated images. She also showed you how you can use these filters in the inventory to define the devices that have vulnerabilities and also are outdated. We've mentioned this before, but obviously you've got very fine-grained control over that tagging process. You can use the role as well as tags, and that makes it much easier for you. Pre and post checks, Leela covered, so I'm not going to cover this again. It's in the slides for your reference so that you can see how it works. Very flexible, very powerful, and makes it easy to go through some checks to see that the upgrade has succeeded in the way that you expect. Okay, so recommendations. The main one for me is to separate out distribution from activation. And the reason for that is that if you think about change windows, and depending on where those devices are, it's not necessarily a finite amount of time that it's going to take for that distribution to occur. It means that your change window can be smaller because all you need to do is to factor in the reboot time of the device, and it radically reduces the amount of window you need to allow for with the upgrade. For wireless, we have a couple of choices. So we're able to do in-service software upgrade, not only for wireless devices, but for wired ones that support it. And we can also do rolling AP upgrades, which is a feature that the 9800s have. And essentially what that does is you tell it the percentage of devices that you want to upgrade in a single point in time, and it will pick a number of access points that can see one another and choose a percentage of those to update at a certain point in time, and therefore you get service. And I can see some people smiling and giving me the thumbs up because that's a pretty cool capability. Those of you who are using external file servers, you can use an external file server in DNA Center. They are defined in the settings. Now, there is a caveat that you need to know about this. When you define an external file server, everything that is in the golden image repository of the DNAC is going to be replicated to that device. So just take that into account, because if you have 1,000 golden images in DNAC or 1,000 images stored in DNAC and you add an external file server, it is going to be replicated across. So you might want to think about how you manage those images and maybe just trim them down. If you've got old images in DNAC that you don't need, you might want to get rid of those. The other thing you might want to do is to put in a feature request to make a wish to make that more customizable. Also, as Leela said, we're moving towards install mode as being the recommended way of doing these upgrades. We don't have a conversion process at the moment, but encourage you to move towards install mode if you can, because there are a lot of advantages with install mode. In terms of software image management with ISSU, yes, that is supported. The way that that works is that DNAC will contact CCO, and there is a matrix on CCO that defines the valid ISSU images. So you're probably aware that you can't just upgrade from any image to any other image in terms of ISSU. There's a very strict matrix around long-lived releases and which versions of code are supported. That is in an XML file that DNAC will download so that it won't let you get into trouble if you try to do ISSU on an image pair that are not supported. The other thing that we have changed in, how many people are running code that is earlier than 2.3.3? Yeah, a few of you? So encourage you to upgrade to 2.3.3, particularly if you're doing wireless. And the reason for this is that we changed the way that we did the distribution in 2.3.3. Prior to 2.3.3, if you were to upgrade a wireless LAN controller, all we would do in distribution is just get the image onto the controller. And that was it. What happens next with wireless when I go to activate? What's the first thing the controller does? Downloads the image to the APs, right? How long does that take? It depends. It depends. But proportional to the number of APs that you have. So that meant that the activation phase depended, because you had to get the images down before you could activate them. So from 2.3.3 and above, the distribution process not only copies the image to the wireless LAN controller, but also does the AP image download, pre-download, so the image is ready to go, which means that the activation process is far faster than it was before. Okay, habit number 5, AI/ML. How many people are playing buzzword bingo this week and are expecting that they haven't seen AI/ML yet? Anyone? Really? You haven't heard AI/ML yet? Wow. How many sessions have you been to? So I'm joking. So obviously, AI/ML, buzzword, massive amounts of hype around AI/ML. I always find it interesting when people start talking about how AI/ML is going to solve, world hunger and all of the problems in the universe. How many of you have kids? How many of you have seen how many images it takes to train a 2-year-old to recognize a dog? 3 maybe, 4. And it can recognize a dog from all sorts of different angles, right? How many images does it take to train a machine to recognize a dog? A couple of million? And there's still ways that you can fool it, right? How many of you use CAPTCHA as part of an authentication process to verify if you're a human or not? Find all the traffic lights in these 5 images. It's not easy to do, right? So there are some problems that AI works really well for. There are some problems that it doesn't. But what we do know is that where you've got vast quantities of data and you're looking to find deviations over that vast quantities of data, then AI and machine learning tools work really well. So one of the things that we have done differently in terms of AI, the AI infrastructure that we have on DNA Center, is we've taken advantage of the fact that we have an on-prem device. So our AI engine is in the cloud, but we have DNA Center on-premise. Now, what does that mean? Well, the thing it means is that if you think about privacy of data, there's something that we can do that other people can't do. And that thing is encrypt the sensitive data before it leaves the environment. So when the insurance data comes from the wireless LAN controllers into DNA Center, before it leaves DNA Center and goes to the AI cloud, DNAC will encrypt any sensitive information with a key that it owns that you have access to and no one else does. So any of the sensitive information is encrypted from the moment it leaves DNAC. It's encrypted at transit. It's encrypted at rest in the cloud. But if that cloud is compromised, what do you get access to? An encrypted version of Adam Radford. Not very useful, right? So your next question is, if you've encrypted all of that sensitive data, then isn't that data useless in terms of running those models and algorithms on? Anyone thinking that? Well, I know the ones of you who are smiling are saying, you know that it doesn't matter because the first thing that you do when you get any sort of non-numeric data in an ML algorithm is you tokenize it and you turn it into a number because that's the way the algorithms work. So I will use hot ones encoding, I'll use some basic encoding scheme to take that text and turn it into some numeric representation of it so that I can use it in my models. So the fact that it's encrypted doesn't really matter because I'm going to, as long as it's going to be unique and consistent, then that's all I really care about. So we use these engines in a couple of different ways. The first way we use it is the obvious one, which is around deviations from normal behavior. How many of you are using Prime and you've got static thresholds set for certain events that you're interested in? Yep. And those events, those thresholds are either too high or too low, right? If it's too high, you don't see enough. If it's too low, you see too many, and you can never get it right. So the power of these algorithms is working out what normal behavior is over time, and then telling you when there's a deviation from normal behavior. So if I think about something like onboarding time, that might vary on Monday morning compared to Friday afternoon. So I'm able to take that into account, and if there's a deviation from what I expect at that particular time of day of week, I can flag that as an event or an issue. The other thing that the algorithms do a very good job of is this notion of clustering. So what they're able to do is to take a vast quantity of data and categorize it into small, medium, large, or good, okay, bad. Onboarding time, for example. Good onboarding time, okay onboarding time, bad onboarding time. Now, the reason that the clustering is important, if you want to do comparisons between different things, you can look at the percentage of good, medium, poor onboarding times between different types of devices, for example. So my iPhones are performing really well, but my Windows devices are not. I can use the clustering technology to be able to make direct comparisons between the onboarding times. Because mathematically, if I do something like just take the average, that's not very effective because it can be skewed by outliers. So we're able to do direct comparisons and use these algorithms to see the difference between different models of access points, for example, or different types of client devices. There's a lot of different ways that we use this data in DNA Center to give you insights into how well the network is performing. The other way that we use the algorithms is that we're increasingly seeing IoT devices connecting to networks. And what's the key thing that an IoT device doesn't have? Normally, it's a person behind it. So there is no human authenticating that device. What's the business model normally behind an IoT device? Well, low cost, speed to market, security not so much generally, right? It's an OEM, it's a stack that's come from somewhere else. And we've all heard the stories about IP-enabled fish tanks that are being used to exfiltrate data from casinos, IP-enabled vending machines that have been used to DDoS campuses. So identifying IoT devices is a real challenge. So what we're able to do is we're able to take into account all of the different streams that we have around metadata around those devices. You know, the common things like MAC address can be used, not terribly effective, but it's a factor. DHCP options, you know, there's a variety of different things that we can use. We can use some of the profiling information that ICE has. But we can also use, most importantly, metadata around how that device behaves in the network based on the traffic patterns and the traffic flows to help identify the type of device. So it's almost like a fingerprint based on how the device behaves, some other attributes that we know about it to try and identify it. So there's a lot of work that we've done around this notion of endpoint analytics, which is identifying these devices. Now, we're seeing this becoming particularly important with IoT devices, and what that means is that, you know, we can classify a device and we can work out what type of device is by the way that it's behaving. We make recommendations for you, so if all of a sudden you decide you're getting a Bosch IP-enabled coffee machine, we can come up, or we can make a recommendation based on others that we've seen in other customers and let you know. And then you're able to profile that, or DNA Center is able to profile that device and work out exactly what it is. So I'm not going to go through this slide in terms of how it works. This is for reference. There'll be a test on this later before you leave. No, just joking, no test. Once we've done this, we're able to generate a trust score. So this trust score is based on how what we think the device is compared to how it's behaving. The other thing that we're able to do with these devices is to look for other types of misbehaviors that may occur. How many people are concerned about users bringing a home router into their network with an open SSID on it, running NAT, and having free access to the network? Yeah? So we're able to detect whether a client has been natted on the way through. So this is a way that we can detect the presence of a NAT device on the inside of your campus. We can also detect things like concurrent MAC addresses. Network engineers, what is something that cannot happen with a MAC address? It cannot be seen on two different layer 3 networks at the same time, right? If we see that, we will let you know, because chances are what? Someone's stealing the other MAC address. Anyone using MAC-based authentication? Yeah? Good way to get around that, right? Steal a MAC address. So there's a lot of things that we're able to do here. The other thing that we can do is we've tied into Identity Services Engine, and there's this little button down the bottom that says Apply ANC Policy, and that's a policy that you define on ICE that gets applied to that device to remediate it or kick it off the network, depending on what policy you've defined. So the third example of AI tools is radio resource management. How many people are using RRM on the wireless LAN controllers? Yeah, it's a pretty cool feature, right? Takes into account all of the data around the access points in terms of what they see, in terms of neighbors, and then tries to work out the optimal channel plan and power for a radio on the access point to optimize the performance of the network. What are the issues? How many people love configuring it? No? No? Yeah, it's not that simple to configure. The other challenge with it is that it has 10 minutes, because it's running on the controller, it has 10 minutes worth of data. So every 10 minutes is Groundhog Day. It starts to recalculate based on the previous 10 minutes. It doesn't really have the concept of a busy hour, so it's likely to make changes whenever it can. And it doesn't understand the difference between buildings, because a controller might have access points in multiple buildings, and you might want to configure buildings in slightly different ways. Probably the biggest challenge is that it doesn't give you any visibility around what it's done. Anyone seen that with RRM? It's like you turn it on and you just close your eyes and hope. So understanding what it's done, understanding what it's doing is something that we would like to add to this. And the other thing is that you can't really have a simulation mode. So if you do it, what is the difference in performance based on enabling this RRM, this radio optimization? We don't really have a way of doing that. So what we've done is we've taken all of the data from the wireless LAN controllers and we sent it off to the cloud. And we get the cloud to process that, to work out the optimal way of configuring the network and to make recommendations back. Now, the beauty of this is that you all of a sudden have a dashboard that shows you how well the network is performing. It shows you all of the changes that have been occurring. It even has a simulation mode where you can do a what-if analysis and see what would happen if you allowed those changes to occur. You can also define a window that says it's a busy hour, so please don't make changes, because what happens if you change channel? Clients get dropped, potentially impacts performance, so you need to be careful about when you do this. Okay, habit number 6, APIs. How many people have a programming background? How many people have Python skills? How many people want Python skills? Go to the DevNet zone. Go to the DevNet zone. So Python is probably the most popular language for network engineers, and the reason for that is that there are lots of libraries, lots of modules that allow you to do things quickly, so that's why it's popular. How many people are interested in the APIs in DNAC? Why? Faster? Okay, faster. That's an interesting point. Faster. Hold that thought. Have a slightly different perspective, but I understand where you're coming from. There are 3 reasons that we use APIs. Faster is one of them. Well, I have a slightly different perspective on faster, but the reason or the use case for APIs around faster is based on automation. And my theory around automation is that the reason that it's faster is because it's more deterministic. If I make an API call 100 times, I expect the same result. What happens if I drag and drop something using a user interface? Am I going to get that right 100 times? Probably not. Probably not. So one of the use cases I think that's really important is around automation. It's about deterministic behavior, but it also leads to things being faster. And it does lead me to my fundamental saying around the importance of APIs and user interfaces. How many people love GUIs? Love UIs, love user interfaces. Yeah, they're good, right? They're good. How many people play golf? How many people who've played golf have heard of this phrase or saying? Drive for show, putt for dough. You can drive 400 meters down the fairway and it looks fantastic, but if you can't sink a 3-foot putt, you're not going to win too many golf tournaments. So my saying around APIs is that GUI for show, API for dough, because it's faster, it's better, it's more reliable in certain situations. So my view is that APIs allow us to scale and allow us to do things much faster. Now, there's really 3 use cases for APIs. We've mentioned one of them, which is automation, and that's about determinism, and it's about speed, because we don't have to go back and check and double check and triple check that we've done the right thing. There is another set of use cases that is pretty important, and that's integration, so tying things together. Identity Services Engine and DNA Center have an integration. It's an API-based integration. There's lots of integrations that DNA Center has. It ties into Talos, it ties into StealthWatch, ties into a whole bunch of different things. DNA Center has an integration into WebEx Teams so that if you have issues, they can be automatically populated in a WebEx team space based on the priority. Lots of different things that you can do around integrations. But to me, the most important use case is the third one. Any ideas what it might be? I've got the automation, I've got the integrations. Sorry?
Less dependencies.
Less dependencies? Maybe. How many people find that DNAC does everything that they want today? No gaps. Everything you want to do, you can do in DNAC right now. Anyone? Any product does absolutely everything you want. Third one's around innovation, right? Because the user interface is a restriction. It's a set workflow in terms of how things can be done. It's not the full set of capabilities that the platform has. The APIs allow you to do that because they allow you to take those APIs and make changes in terms of how the way that DNAC works. So there are lots of examples around how people have innovated on top of this. For example, Leela's favorite topic, which is SWIM, software image management. In DNAC today, can I easily change the way that I activate switches? So if I have distribution and core and edge switches, can I change the way that I activate those? Can I easily decide to activate the edge switches first and then the distribution switches second? Not really, right? Could I do that with an API call or a set of API calls? Yes, I could. For a given area or building or site, show me all the edge switches, use the API to do the activation, show me all the distribution switches, use the API to do the activation. There you go, you've got the capability that you wanted. So we've made it easy for you in terms of Python. I know there's a bunch of Python people here. So there is a Python SDK called DNA Center SDK, funnily enough. That will make it very easy for you to use the APIs. You can download it, very easy to use. For those of you who want other languages, we've got Go in terms of an SDK. We've also got Ansible bindings and Terraform providers as well. So there are some other scripting languages, there are some other things that we're doing around the APIs that you can take advantage of. One of the other things that I meant to mention here, and I covered this slightly before, is that with the issues that we have in DNA Center, one of the things that we've done is we've allowed you to do a native integration into WebEx. So you used to have to code this before. And I wrote some sample code that would allow you to take a webhook and put it into WebEx Teams space. But the beauty of that sample code is that if you have Microsoft Teams or if you have Slack or if you have some other messaging system, you can take the code that I wrote, change the couple of API calls that go to WebEx, and then use Microsoft or Slack or whatever APIs and get your own integration if you want to very easily. How many people would like to use templates a little bit more flexibly? Yeah? Anyone? Templates? Be able to take a template, put it on any device, give it a set of parameters, ready to go? Okay. So here's a very simple example of using a script to do that. Now, it's an educational script because I wanted to expose the way that the APIs work. The first thing I'm going to do here is I'm going to look at the show run for a particular interface, which is gig 1/0/4. And you can see that there's a description which is just :auto. I am going to run the template.py command, which is really just going to, it's a script that's going to dump out all of the templates that I have. And there's a template called Atom Intdesc, which is interface and description, which is a template that takes an interface name and a description and will push it out. So I'm going to have a look at that template. And again, you can see that don't be put off by the code. It's showing what's happening behind the scenes. It's educational. You can see that the code that, or the template that's going to get pushed here is going to be interface, whatever the interface variable is, description, whatever the description is, and you can see it being highlighted there, and it's going to append the string auto at the end of it. So I need to populate the values. I give it a device. I give it a set of parameters, so you can see that the interface and the description have been provided. That's going to get pushed out to the device. And again, I'm showing you the debugs of what's happening in terms of the payloads behind the scenes. So don't be put off by that. It's just to show you what's going on. And you can see that it took, well, you can see what it actually applied. And then if you go and look at the show run, you can see that that's been updated. And you can see that Adam:auto is the string that's been added to description. Yes, that is a trivial example. It's trivial for a reason. It makes it very easy to understand what's going on. But that could be any template. It could be any set of variables or parameters that you pass into it. And it gives you tremendous flexibility in terms of what you do with templates on DNA Center. That code is available on GitHub. There's a repository on GitHub under the DevNet site. So if you go to the Cisco DevNet org, and if you look under the repository and you search for DNAC, you'll see there's a whole bunch of things. You'll see that there's DNAC template programmer, which I think is my code. Yeah. So that's an example. There are a whole lot of other examples. So I have code that does things for SWIM. So if you want to do the SWIM distribution thing with distribution switches and access switches, you can use the SWIM code to do that as well. Heaps of different examples there around how you can use simple scripts using the APIs to innovate on top of what DNA Center does today. Okay. How many people have had issues upgrading DNAC? No one. Okay. I won't worry about this. It's being recorded, isn't it? Yeah, so there have been some challenges with upgrades in the past. You need to make sure that DNAC is healthy before you upgrade it. That's probably the key thing that you should take away. How many people have heard of a tool called Aura? How many people have used it? Yeah, awesome. So I'm one of the 3 people that wrote that tool. And I actually wrote it as a proof of concept about 3 years ago. And I never expected it to go into production. Well, it's not in production, but I never expected it to be still running today. And the design goal that I had for Aura was I wanted to have something that would run a set of automated checks on DNAC without causing any damage to ascertain how healthy DNAC was. Because prior to that point, we were sending an escalation team out to do a sanity check of DNACs, and it didn't make sense that they spent a couple of days going through and collecting all of these logs and analyzing them and trying to work out, if the DNAC was healthy or not. So Aura is a tool that was designed to run a series of health checks without causing any damage. It doesn't make any changes, and it just gives you a report at the end of the day to say, you should have a look at these things. They might be causing concerns. It runs on pretty much any version of DNAC. I hope there's no one running 1.2 anywhere yet, or even 1.3. It supports the latest code as well. It generates a report, and that report has a summary looking at the DNAC, looking at the number of checks that have been run, the number that have succeeded, the number have failed. It's probably more than 32 pages now. This is 1.64. The latest version is 1.68. And essentially what it does is it goes through a whole range of checks, and then you scroll down and you get more and more information around the things that failed. And then there's the detailed results of it running. So it's looking to see the version of code that you have, your member ID, making sure that you don't have the default admin password, CPU load, disk layout. There's about 150 different checks that it goes through, looking at certificates, whether they're still valid or not, a whole range of things. You can download it from GitHub. So if you search for DNAC Aura, you'll see the GitHub repository where I publish it. And then all you need to do is basically download it to your DNAC and run it, and it will generate that report. In terms of how you do this, unfortunately, it does require a limited knowledge of shell. So we recommend you run it in, or have it in the DNAC Aura file. Actually, one little thing you'll notice here, when I connected to my DNAC, I did an SSH. Anyone know what this command does? Server keep alive interval equals 3. So that basically sends a keep alive packet every 3 seconds. I could probably make it more, but every 3 seconds. And the reason I do that is that if I leave that out, there's an idle timeout by default on DNAC of 10 minutes. And Aura usually takes longer than 10 minutes to run. Not much longer, but usually takes longer than 10 minutes to run. So I've had a number of people complain that Aura didn't work properly because it stopped executing halfway through. And my first question is, have you handled the server keep alive? And the answer is no. Well, your session is timing out. You can either press enter every 10 minutes to keep it alive, or you can just put in the option. Most of the clients will have that option as well, so it's not a big problem. So once you change into the directory, you can just run it. And one other thing that I want to mention here, and people always make this mistake, depending on what's happened with the commands that you've run on DNAC, you will get prompted for either the admin username or just the password. Now, I can't tell which one you're going to get prompted for, but you just have to read the text properly. So you can see it says username for that URL. Often it will say just the password, and it's based on whether the last authentication was successful or not. But sometimes people put the password for the username and then wonder why it doesn't work. So put in admin and the password, and it should just run. So that will run through, run all of the checks, and you'll need the SUD password as well. That'll run off, do all its stuff, and then you'll be left with that report. With 2.3.3, there is a restricted shell. Has anyone come across that? Does everyone know how to get around that? Underscore shell will give you access to a full shell. You can run a maglev command to get that all of the time. From DNA Center 2.3.4, that restricted shell can't be turned off. That's a security requirement, some of the FIPS certification that we've been going through, so you can't turn that off. You will need to get a consent token from the TAC, so you can run underscore shell, and it'll tell you that it's a restricted shell. You need to get a consent token. It'll ask you how many days you want it to be valid for, and TAC can give you access to it. There is a built-in validation tool that is coming. It doesn't have the full set of checks that Aura has, but we are building this capability natively into DNA Center. And when I first wrote the script, my hope was that this would have happened pretty much straight away, and I wouldn't have had to continue developing the script, but for whatever reason, it hasn't. And the number of checks will grow over time. So in the meantime, we will continue to maintain Aura because there will be a lag. Probably it's going to be another 12 months that I'm going to have to work with the team and keep that going, but we will do that. But over time, it won't be a problem because the validation tool will be built in and will do exactly the same thing. Okay, so takeaways. Device controllability to maximize value. Leela spoke a lot about the telemetry and the insights that you can get. Software image management, which is everybody's favorite topic, is absolutely critical. We spoke a bit about the AI, ML tools and the architecture that we have and how that's a little bit unique. APIs, automation, integration, innovation, we spoke about. And the Aura tool in terms of automated upgrade readiness assessment. So as with any habit, I think the key thing is not to get hung up around perfection. It's just to get out there and start doing it. So I encourage all of you when you get back to pick one of these a week and at least have a look at one of these if you're not already doing it. Don't worry about doing it perfectly or doing it everywhere, but just try to do it a little bit each week and tick one of these off each week. I want to thank you for taking the time to attend our session. There are a whole range of other sessions around other related DNAC topics, everything from the virtual appliance. Leela and I have got a session around prime migration tomorrow, which is a subset of the workshop that we had on the first day. We do encourage you to fill out the surveys. I know it can be onerous. It's something that we take very seriously. The results of those are something that we all have a fairly hefty competition around, so encourage you to fill out those surveys and to be nice to us. I think the environment in the room has been great. You have been wonderful in terms of taking your time and providing attention, and I want to wish you a wonderful Cisco Live, and thanks for spending time with us. Thank you.